All right, this is review for sketching, curve sketching with calculus. So let's write this down together. And what are the steps we're going to use to analyze this using both pre-calculus tools and calculus tools, and then to be able to sketch it? So pre-calculus is like the x-intercept. Well, I'm going to factor out x squared, and 0 and 3 are my x-intercepts. My y-intercept, I plug in 0 and I get the answer 0. The end behavior, how do I write that as a limit? So I know the power term is x cubed, so it goes up to the right and down to the left. So for the right end behavior, we write down as x approaches infinity of f at x, and the right end goes up. And the left end behavior as x approaches negative infinity of f at x, and that's negative infinity. What are some other things we can find? Well, I can take the derivative, and that's 3x squared minus 6x. Again, make it equal to 0. We can factor it and know that the two answers we get are 0 and 2. Those are called my critical numbers. So we can draw a number line for the first derivative. And then if we plug in -1, we have a negative times a negative. If I plug in +1, that's a positive times a negative. And if I plug in a number bigger than 2, like 3, that's a positive times a positive. So I know that there's a maximum at 0 and there's a local minimum at 2. To find the y-coordinate, we just plug back in. So if I plug in 0, the answer is 0. If I plug in 2, 2 cubed is 8. 2 squared, 4 times, that's -4. One more time. I'm going to take the second derivative, make it equal to 0, and I'm going to solve it. So this answer is not -1, sorry, it's +1. Again, draw a number line, just with +1. And then recognize a number smaller than 1 will give you a negative answer, and a number bigger than 1 will give you a positive answer. So that there's a point of inflection at +1. So if I plug 1 in here, it's 1 take away 3, so there's a point of inflection at 1, -2. Now, if I sketch this, I'm going to plot the points I just came up with, like 1 and -2. I'm going to plot the 0, 0, 2, -4, and the intercepts, which are 0 and at 3. And then I'm going to put all the pieces together. So I know this function increases and concave down. So with the end behavior, this increases is concave down all the way to here. So I know the left end goes down, it increases, it's concave down, then it's concave up, and the right end goes up. So the right end goes up, the left end goes down. I have my maximum, I have my minimum, I have my point of inflection where the concavity changes, and it's all together. All right, let's do one more together. And see if we can analyze this together. For this one, I'm going to give you derivatives too, so you don't have to find the derivatives. So you can write these down. And then we're going to start again. So the x-intercept. So if I factor this out, two numbers that multiply to 4 and add to 4 are +2 and +2. So if I factor it, this is what it's going to look like. So we have one x-intercept at -2. the y-intercept, plug in 0 for x, and it's undefined. So that means there is no y-intercept. End behavior. We can write this end behavior as an asymptote. Notice power term over power term, it's y equals 1. Now we're going to take a look at the derivative. So what are the critical numbers? So if I take negative 4x subtract 8 equal to 0, I could factor out a negative 4 and recognize there's one answer, which is negative 2. And then I draw a number line. And then I plug in, if I plug in negative 3, and negative times the negative is positive. If I plug in negative 1 or 0 or any of those other numbers, I get negative. So there's a maximum at negative 2. If I plug back in here, negative 2 plus 2 is 0, and 0 divided by negative 2 is 0. So we have a maximum at negative 2, 0, and we have no minimum. And it's increasing from negative infinity to negative 2, and it's decreasing from negative 2 to infinity. We're going to take the derivative again. Oh, we already have the derivative. We're going to take the second derivative, this the numerator, equal to 0, that's a 24. And then if I solve it, I get negative 3. So if I draw a number line for that, for negative 3, if I plug in a number smaller than negative 3, it's a negative divided by a positive. If I plug in a number bigger than negative 3, it's a positive over a positive. So we do have a sign change. There's a point of inflection at negative 3, and then we go back in here to solve it. So negative 3 plus 2 is negative 1 squared. That's 1. And then negative 3 squared here is 9. So we have a point of inflection at negative 3 and 1 over 9. We're going to graph this. So we have point at negative 2. We have another one at, so at negative 2, we have another one at, there's no y-intercept, at negative 3. We have an asymptote at 1. Oh, we also have a vertical asymptote, so let's look at that real quick. So x squared, look at the denominator. The domain is x can't equal 0. So that gives us a vertical asymptote at x equals 0. All right. And then we have to figure out what is this graph. So I know the end behavior. I know it is concave down. Look at this. Just looking this quick. So into the derivative, if I plug in, so it's increasing and then decreasing. How does that create? I made some mistake somewhere here. Because the graph, so at negative 2 and 0, we said was a maximum. What mistake did I make? So negative 3 and 1/9. And negative 2 and 0. I mean, clearly at negative 2 is a minimum. So what did I do wrong here? So if I plug in negative 3, I know what I did wrong. So if I plug in negative 3, That is a positive, but negative 3 cubed is a negative. So it's a positive over a negative, which is negative. And then if I plug in a number bigger than negative 2, like 0, that's a, or 1, that's a negative over a positive, which is negative. Let's try that again. Plug in a number bigger than negative 2, so like a negative 1. Oh, we also need to put down the asymptote. That helps too. There's 0. We need that asymptote. So this is going to be positive. So this is actually a minimum at negative 2. And then after 0 is again decreasing. So if I put in positive 1, it's decreasing. All right. So what I forgot to do is put in the asymptote on my number line. I should also put that here on my number line. So if I plug in a number bigger than 0, this is also concave. So both sides are concave up. All right, let's see now if we can put it together. So this is concave down. And then it's concave up. And then it's concave down. So it's concave down, concave up. We have a minimum. Here, it's concave down, and we have the end behavior that. And it's fine that it crosses here. At a vertical asymptote, it's either going to go to infinity or negative infinity. So it's definitely going to infinity. All right, Mr. G Math, over now.